Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of circumference and area of circles. This is standard 7.9b in the great state of Texas, and we are using item number 23 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a company's logo, and it's designed using 3 different size circles, and we've got 2 of these diameters. Looks like a snowman is what it looks like here, but we need to find the measurement that's closest to the area. All right, so the area is the inside of the largest circle. So we've got this large circle right here, and remember the area is the inside, so we need the inside. And so we have to use something different when we're looking at the area of a circle, because normally when we think of area, we think of length times width or base times height, but there's no sides here. There's no corners. These are not polygons. And so the area of a circle is simply pi r squared. So our r is our radius. But here's the interesting thing. We don't even have the center of this circle labeled for us. I'm assuming it's about right here, and the radius, right, is going to be from the center to the side. Now I've got the centers of both of these tiny circles figured out, but I don't have the center of the actual circle, so I need the radius of the larger circle. And if I could do that, I just square it and multiply it by pi. So let's see if we can figure out what the radius of this larger circle is. I don't know what the radius is, but you know what? Look at what I've got. I've got a dotted line that goes from the top to the bottom through the center, and that is called the diameter. So my diameter, remember, is a line that goes from the one side to the other. That prefix di means 2, so it cuts it in half, and that's simply double the radius, right? So if I take this radius and double it, I'm going to get the diameter. So I've got a measurement of 6, and I've got a measurement of 12. So I'm going to add those two together. So I'm going to say 6 plus 12 equals 2r. So really, my diameter is going to be 18. All right, so 18 centimeters equals 2r. So you know what? I just want to divide both sides by 2. So if I cut my diameter in half, I'm going to get a radius of 9 centimeters. All right, so now I know that this radius right here, r equals 9 centimeters, because the diameter is 18, and I just cut that in half. All right, so now I can plug that into this equation here. So I know that this pi is equivalent to 3.14. It's actually an irrational number. It's close to 3.14. That's why we say which measurement is closest, but it's actually an irrational number that goes on and on and on and on and never stops. So I need to multiply that by 9 squared. Now remember, 9 squared does not mean 9 times 2. That's the diameter. It's 9 times itself. So I need 3.14 times 9 squared is 81, because that's what 9 times 9 is. All right, so if I get that, I should be good to go. So let's just set up my 3.14 times 81. Lots of big multiplications when we're dealing with area of circles, and they're all going to involve decimals. But this first row is obviously going to be pretty easy. 314. It's this second row that's going to take a little bit of work. 8 times 4 is 32. 8 times 1 is 8. Add that 3 is 11. And then 8 times 3 is 24. Add that 1 is 25. So I've got 4, 3, 4, 5, 2. But remember, 2 digits behind the decimal in my factors mean I need 2 digits behind the decimal in my product. So 254.34. And remember, we were dealing with centimeters. So since we did 9 times itself, it was actually 81 centimeters squared. So we'll bring that down here. And so that's our answer. D, 254 and 34 hundredths centimeters squared.